Hey there, math fans. Going to talk about topic 1 for exam 1 in our Math 120 course. Going to talk about linear equations and modeling. This is not the sequence in which we taught the materials. It's just the sequence I thought would be the easiest to step you into preparing for the test. We'll do that question in just a moment. I don't want to waste any time here, but this is the sheet I made for you. It has review sheets. If you needed to review this topic, I would click on the chapter 4 review, which reminds you about the equations of the line, gives examples of several different types. That's what I'd be doing. What I'm about to do is talk about topic 1 page. So what I've done, and let me know if this has been helpful to you, I've taken screenshots of a couple kind of typical examples. At any point here, you can click on this, find a nice printout of the example, try it on your own, see the solutions. They're all there, the midterm, the solutions. There's plenty more in our exam archive, but I picked trying to sort them by topic. So here are 2 that kind of highlight a couple points, and then I have a few additional ones here, okay? So I feel like if someone did those 5 questions, they would be more than ready for anything to do with linear modeling. All right, so those are the questions I'm going to talk about in varying amounts of detail. Okay, so here we go. I read this question, I open the exam, imagine you're taking the test, you just walked in, you're sweating, whatever, you're nervous about it, you got your calculator sitting out, and you read the average monthly rent for an apartment in Funtown, and you're like, I don't know what Funtown is, I don't know what tabulated is. Keep reading. Let X be the year, okay, that tells me some information. F of X is the rent in this town, this is the rent. Assume that the average rents are linear functions. That immediately sends me down the path of finding the equations. I already know, or I have a hunch, that I know what this problem is going to look like. And if I was a student, I wouldn't necessarily write that yet. I would probably read on, but I'd be like, okay, I already know that I'm going to get points because I'm going to find the equation of both those lines. Each of that is worth partial credit. And that's already on your way to like half credit. Okay? So I'm trying to sort of put people at ease because I'm getting these messages with people that have a lot of distress here, but I think everyone can control this piece. If you see linear functions, find the equation of a line. If you don't do that, that's kind of on you. Okay, find the linear functions and answer the following question. For what value of X will the cost be 500 more in Funtown than Boreville? Okay, so I need to find the equations of the lines, and then I'll try to answer the question. You should immediately be thinking, I need the slope. Make sure your y value is on top. I'm not trying to trick people with these questions. Okay, we're getting 300 over 30. And I'm doing all these questions fresh. I wrote this years ago. I don't remember what the answers are. I want to experience it like you would experience it. Okay, so we have the slope. We're going to use one of the points. 1960, 100. Done. That would already get you some credit, probably a couple points. All right, let's do the next one. M is equal to 210, 150. We're going to do 19. And you don't want to, on a question like this, be looking down at a note sheet. In fact, you should, when you're practicing, be timing yourself a little bit. If this question takes you more than 10 minutes, there's something going on. This should not be a 10-minute question. Okay, if you want, you can expand out, but let's just read the question. What does the question say? It wants to know when this is 500 more than this. Now, I do find that people tend to read those questions wrong, and I did post about this when it came up in the homework, but let's comment again. I always ask the question of which is going to be bigger. I find that to really help me think. When I read that question, to me it looks like Funtown is bigger. It doesn't look like, that's what it says. And that helps me. Because what I find is students think that they're supposed to add 500 to the bigger side, but that is not true. You add 500 to the smaller side. When you take a number, and I do this when I did my previous post, if I have one number, let's say that Boretown was 200. What does it mean to say that Funtown is 500 more? It means you add 500 to the smaller thing to get the larger thing. That's what this is saying. I just find people tend to want to add the 500 to the bigger thing. Okay, so now we're going to solve. As I solve, I think I would expand. So the rest becomes algebra and arithmetic. So we'd have 10x minus 9. I'm just going to quickly hammer this out. Plus 100 is equal to 2x minus, and this is probably what I use my calculator for, 2 times 1960, 3920, plus 150, and then we're pretty much there. I don't want to spend too much time here, so subtract, we're going to get 8x. I'm going to move all the other numbers to the other side, so it's going to be 19 this, and I'm going to subtract 100, and I'm going to subtract a 3920. Some students say they want to see these details. Oh, and look, I tried to make a mistake. I didn't copy. I was like, where's that 500? 500. Okay, that's that number, and I'm going to divide by 8, but I can write this if I want. And when you're taking the test, you don't have to write every excruciating detail, but enough that I can follow along. So I'm getting x is 28.75. Done. If you want to check your work, you can click on there, go to the exam archive, click on the solution. In that time, I wrote my solutions on paper. I don't do that anymore, but there you go. So my hope is to kind of put people at ease and just show you what it really entails to do these exams. Because I think people are making it into something bigger than it actually is. Okay, let's look at the next one. Brad is standing 500 feet north of Matt. Okay, I'm already feeling like I need to draw something to attach to my brain. I think I'll put Matt here at the origin. You don't have to. We're going to put this at 500. And then we're going to go, Matt runs toward a location. So I'm going to call this north, east. So this is exactly how I'd be thinking through the problem. 600 feet east, 30 feet north. I said 600, but I meant 60. Okay, and he runs there. At what location will Matt be closest to Brad? So this would be one of these things I'd be like, wait a second. This came up in the homework. Angela, Tiff, and Mary, and several other things. And we should have somewhere on our note sheet that's like, all right, this is about perpendicular lines. And there's a line in the graph. So I would immediately find the equation of the line. So the equation for Matt is 30 minus 0 over 60 minus 0. It's a half. It goes to the origin, so y is a half of x. Done. That's the equation for Matt's line. And then because you'd have this remembrance from having done this a few times in the homework and us talking about in class, the next line you would draw is this, and you would write that as perpendicular. And you would say, okay, for Brad, that means I can do the negative reciprocal slope. So this is kind of one of those things that if you don't know this, that feels more like a lack of preparation thing, because that's a topic we saw a few times. It goes to the point 0, 50. Oh, so I can just write, that's my y-intercept. Done. Now I need to find the intersection. That's what the question's asking. How do I find the intersection? I substitute. 1/2 x is negative 2x plus 50. If you want, you can just to do an example, I'll change it to a decimal. So I did 2 plus a half, divide 50 divided by 2.5. Oh, what is that, 20? See, I really don't, you can see how little I use the calculator. And I can't even type it in right. 50 divided by 2.5, 20. Done. That gives me the x value. I can plug into either one of these to get the y value. Done and done. Again, trying to put you at ease. Do you see that there's a line? Find the equation of the line. I'm not trying to trick you on these tests. It's going to be concepts you saw in the homework. Okay, at this point, we'll kind of switch gears. Maybe I won't do all the details, but let's read another one just to sort of reinforce. In 1990, the population is this. Assume it's a linear model. Then I have this other population. X is the year. I feel like we just did this. So I'm going to find the equation for Mongo. It's a linear equation. They gave me some points. So let's find the slope. They said that it was 20,000, sorry, when the year was 1995. I'm just reading the question. It said that it was, I've never done this question before. It's the first time ever. 1980. I didn't write this. It's some other instructor's exam. I just flipped through old exams looking for these questions. 15. Do all that right? 20,000, so it's 2,000 over 15. I feel like I should know, but I'll just do this. 1,000 divided by 15. Oh, it's not a whole number. So I'm getting this. You can work with decimals, that's fine. If you want to write it as a fraction, that's also fine. But do keep all your digits till the end. Okay, do I have a value? Sure, I get when I put in 1980. This is 18,000. Okay, now I have an equation for both. Hooray. At what value of x will the population of Parn be triple the population of Mongo? Okay, so let's play my little game again. Which one's bigger? I don't think you can read that without seeing it's Parn. So the question is saying, I want to know when this is 3 times this. Shove this here, expand, solve, done. Again, when I'm doing this, I'm not trying to do all the details. You can, of course, ask me more details later. I just want to get you that confidence of you can get started. And pretty much if students can do just what I did, they're already halfway. They've already gotten 50% of the problem. That should be automatic. So I'm trying to get more of us there. Okay, then I found, in flipping around, this was probably the one I thought students would find the scariest and might ask me about. This is more about circles and lines, but it has to do with the same perpendicular fact. We had this question that had to do with the silo. This one's a little easier than that. So let's read a few things on here. It says that this point is 17, 0. It says that the radius is 7, and it says to try to find this unknown point. So I mostly just wanted to recap what we did in that problem. There's multiple ways to do this problem. You do it with right triangles and other things. But I laid it out in the way that we will do it in calculus. Because in calculus, you're not always dealing with circles. And there were 2 facts. The fact was that A and B, this is the point you're trying to find, is on the circle. The fact that it's on the circle tells you one equation. A squared plus B squared is 7 squared. The other thing had to do with slopes, and that they were negative reciprocals of each other. The slope between these 2 things, the hard part is we don't know A and B, but we can write down what it looks like, is equal to the negative reciprocal of the slope from here to here. And the slope from there to there would be B minus 0 over A minus 0. So we need to take that and flip it. That's it. Those were a hard couple facts to make use of, but that was the key to the problem. And if I simplify this one, that's the same as saying B squared is negative A times A minus 17. Your job then is to combine those, substitute, solve for A and B, done. So a lot of people kind of struggle through that in the homework, but at this point you could start collecting your thoughts and saying, okay, that's what we did. Yeah, if I saw it, maybe it looks scary, but we could now immediately start that. Okay, then there's one about goats and kangaroos, just another population. So that was the place I wanted to start, was just, you got to be able to find the equation of a line and find the slope. That's a fundamental skill forever. All right, hope that helps.